New Concepts for Solar Heating and Geothermal Cooling, Aristotle 2.0. Aristotle, 384 to 322 BC, disclosed a way to use radiant solar heat and cool soil temperature to move heat from one place to another, including buildings, both residential and commercial, but he didn't realize it at the time. We have completely overlooked this for over 2,000 years. We pay for these oversights every day. Aristotle is generally credited with first articulating the idea that water seeks its own level. This is commonly illustrated with the U-shaped tube. Adding water at A also raises the water level at B. This is so intuitive and so self-evident that it is seldom mentioned in science textbooks, including college-level physics books. When it is, it's called hydrostatic equilibrium. But here's the shocker and the innovation. If we pump a small quantity of water from A to B, for a brief instant, the water level at A falls, the water level at B rises, but because water seeks its own level, both return to their original levels. This all happens more or less instantaneously. The movement of a small quantity of water from A to B causes all of the water within the conduit to move, and when it moves, it carries its temperature with it. Suppose the conduit was 100 feet, 10 plus 10 plus 80, 100 feet long, and contained 25 gallons of water. Pumping a single cupful of water from A to B causes all 25 gallons of the water to move, and when it moves, it carries its temperature with it. The actual lengths of D1 and D2 are irrelevant. D1, the vertical portion, could be 1 foot or 10 feet. D2, the horizontal portion, could be 3 feet or 300 feet. Water seeks its own level. The configuration is also irrelevant as long as A and B are the highest points and the flow is unrestricted. Water seeks its own level. This leads to new concepts for solar heating and geothermal cooling, Aristotle 2.0. Here are several useful implementations of this concept. In the winter, it can heat radiant flooring with radiant solar heat. It can warm the crawl space to prevent frozen pipes. It can melt snow and ice from the roof, and it can warm outdoor pools and hot tubs. In the summer, it can cool the area over the living space, and it can cool both the attic and the area over the living space. Year-round, it can heat and preheat the cold water supply to the hot water heater. Enhanced condensation of water vapor, dew, and desalination of salt water, all at very low fuel costs. In the winter, radiant solar heat warms the black plate, a conduit placed on it, and a working fluid within it. We can use this heat to warm the working fluid for radiant floor heating. More on radiant floor heating. The heat from a dark panel in the sun flows through radiant heat flooring. That dark panel could be placed in an inconspicuous location, such as over the existing heat pump. Moving 1 cup of water from A to B moves all of the water. The floor may now be the warmest place in the house, not the coldest. In the winter, it can warm the crawl space under a house to prevent frozen, burst pipes. In the lower 48 states, the soil temperature 10 feet down is in the mid-50s year-round. This is warm enough to keep pipes from freezing. So as you see, it's absorbing 55-degree working fluid and bringing it up under the floor into the crawl space to keep the pipes from freezing and also to warm the subfloor a little bit. In the winter, it can melt snow and ice from the roof. So what we have here is a conduit loop. It starts with the flat black plate, which could be placed in an inconspicuous location, such as over the existing heat pump. That plate absorbs solar radiation, it heats the working fluid, and moving a very small quantity of water from A to B at the top of the roof line moves all the water, so it's bringing the warmed water up under the roof where it melts the snow and ice, and it's in a more or less continuous loop. In the winter, it can warm or help warm outdoor pools and hot tubs at a fuel cost very close to zero. Please see the next slide. Here's how it heats a pool. It's transferring heat from the building roof to the bottom of the pool. It moves heat from the roof, where it's all wasted, to the bottom of the pool, where it's needed. The roof could be 80 degrees and ambient temperature could be 20 degrees. This will reduce the heating bill for the pool. For a hotel or motel, or even for a home, extending the pool season means more bookings, more revenue, and less energy expense. It takes a lot of energy to heat water, and this is doing it for free. In the summer, the process is kind of reversed. Here we have a conduit loop. Below ground, the working fluid is cooled to about 55 degrees. It is pumped at very low energy cost to the area above the living space where that 55-degree working fluid cools the air underneath it, which sinks to the living space. It's cooling the living space at very low energy cost. Again, moving 1 cup of water from A to B moves all of the water within the conduit. This is a further enhancement of the previous implementation. Here there are 3 phases. The topmost portion of the loop absorbs heat from the area immediately under the roof. This has the effect of cooling the shingles a little bit, which extends their life. That heat is then rejected to the ground, 10 feet below ground. The working fluid is then cooled to 55 degrees and it's pumped back up to the area immediately above the living space so that 55-degree water makes for 55-degree air, which sinks down to the living space below, and then the working fluid continues back on up through the roof in an endless cycle. Again, it's cooling the roof and cooling the living space at very low energy costs. Year-round, this can heat and preheat the cold water going into the water heater, which reduces its load and its energy consumption. This is something over which we think we have very little control, and indeed, until today, we didn't. The inside coil goes ahead of, under, or inside the water heater, reducing the load. Year-round, this can produce accelerated condensation of clean, distilled water from water vapor, dew. The heaviest dew is just before dawn, the coolest part of a 24-hour day. As the air warms, the dew point rises and the dew disappears. This invention cools a flat metal plate, allowing dew condensation over a greater portion of each day. A small pump, which could be solar powered, pumps 55-degree water from a depth of 10 feet up to the flat plate, cooling it below ambient temperature. The dew continues to form over a longer time period of each day. This is the same process that produces condensation on a cold soft drink can. The ambient temperature could be 80 degrees, but the plate could be 60 degrees. This same invention can desalinate seawater in the same way. The deeper the water, the colder it is because it's further from the sun and cold water sinks. This cools the condensing plate to a temperature below the dew point. The actual depth is irrelevant. It could be 100 feet or 200 feet, So here we have a floating raft. Maybe the ambient temperature is 80 degrees, but the temperature on the condensing plate may be only 60 degrees. Lenses and mirrors enhance the performance and efficiency, concentrating the heat. This process has a US patent. You'll see the number there. The title is Heat Transfer System Utilizing Dynamic Fluid Leveling. I am John Saavedra, and my company is Look for the Power LLC. For more information, please contact me at Saavedra, Saavedra, at Mindspring, Mindspring.com. There's also a website, lookforthepower.com. It needs updating.